If you guys are watching this video, you're not gonna scream and fly away from the scene next time you see a spider. Instead, you'll be amazed at how our robotic field has advanced when comparing the stuff these robot spiders are capable of doing. Nature has prompted some remarkable robot designs, and not just that these robots closely mimic the motion of a spider through some pretty extraordinary tech. And apart from the fact that these bots have 6 to 8 legs, they're designed to do some cool stuff. So in today's episode, we'll be going through some of the top robot spiders in the industry and how they're going to impress you. Hey folks, welcome to The Future Robot, where we bring you the newest and best updates from the field of robotics and AI. For daily videos, please consider subscribing to our channel. Let's get straight into it. Number 1. The T8X Robot Spider. The T8 bot is very similar to a real spider, aesthetically and behaviorally realistic. This is the only robot on the market with excellent and fine movement, programmability, and customizability. The robot is powered by 26 servo motors and a distinctive Bigfoot robotics engine that contains progressive robot algorithms to regulate multi-legged robots. The robot is inspired by the elements the creature does. In fact, its realistic movement has enormous possibilities. Now the company, Robotics, has disclosed on releasing a very inexpensive edition of the bot called the T8X. How about you guys? Isn't it cool? If you want to lay your hands on one, it can be pre-ordered at a fraction of the price of the original. The original T8 is priced at $2,950 and the cheaper version, T8X, is priced at $799. And that's a great deal when compared to the original one. A major part of the T8's appeal is its realistic appearance. An exoskeleton that matches such a pattern was constructed using CAD software and produced using a 3D printer. Using the 3D printing technique is great for prototyping and small assortments of parts, but long printing methods can also be counterproductive but can lead to output tie-ups. Accordingly, the T8X eliminates the 3D printed exoskeleton of the T8, favoring reasonable injection molded flexible parts, and this was the crucial element in lowering prices. In addition to that, it prioritizes the more popular Wi-Fi to switch wireless XP communications and is now recently furnished with a touch sensor and a built-in charging system. Number 2 is the Bionic Wheelbot. Some of you might find this one more interesting than the T8. When talking about the Bionic Wheelbot, there's a lot to say. It's like, this thing can do twice the stunts than the T8 bot. The bot is inspired by the Moroccan flick-flack spider, so it can walk just like any other spider. Apart from that, it can also hurl itself into the air, which is made possible with the help of a combined sequence of somersaulting and tossing on the ground. It's twice as fast in so-called rolling mode than when strolling around. The bot comes with 8 legs just like any other spider-inspired robot, enabling it to walk and roll. The robot's movements are regulated by a total of 15 small motors, which are suited along the knee joints in its torso. There are also 14 automatic locking worm gear units that guarantee that the spider only has to use energy while walking on its legs. And not to keep its body upright when standing still, let's look into the most exciting part of the Bionic Wheelbot. Yes, in the rolling mode, the bot does a dope-looking somersault with its whole physique exactly like the real flick-flack spider. The robot also has an inertial detector, therefore it always recognizes its position when it has to push itself off again to stand still. It is therefore considerably quicker when tossing along the ground than walking, and guess what? It can even overcome ramps of up to 5% uphill. Let's see how this bot manages to move over the ground. The spider hurls itself with a tripod pace while the artificial spider manipulates 6 of its 8 legs to walk, leaving the 2 so-called push-off legs folded up. For every step, 3 legs continue to be on the ground, while the other 3 stay lifted and move forward, and then they're set down on the ground. With the same cycle, the Bionic Wheelbot then shifts the other 3 legs forward, which were just on the floor. In order for the bot to push its long legs rapidly and efficiently, the drives must apply comparatively high forces. For this, they're supported by a spring mechanism. Every knee and shoulder joint has a spring that is primed when the appropriate leg is lifted. When elevating the body, the force momentarily stored at this time helps the matching motor in the counter movement. Even when walking, the Bionic Wheelbot maintains a firm footing regardless of the ground's condition. The Bionic Spider is also capable of turning on the fly. It stands on its 2 longest legs, pushing its body upwards, and then rotates in the desired direction before walking normally. To begin rolling, the Bionic Wheelbot bends 3 legs on each side of its body to form a wheel. And to do so, it firstly draws the rear legs in a parallel instance and then pulls the other legs up after them. The 2 legs fold up while walking, then extends, push the rolled up spider off the ground, and smoothly push it forward while rolling. So you guys might be wondering, what are these characters for? So this action curbs the Bionic Wheelbot from coming to a halt in sandy surfaces and ensures that it can move along, even on a rough landscape, just like its biological role model in the desert. That's all about the Wheelbot. Let's move on to the next spot. Number 3, it's the MX Phoenix Hexapod. When looking at the shape of this bot, you might get moved by its design. This strange robot is one of a kind because it was developed by a Norwegian engineer in his own garage, and it has a more natural looking, more articulate leg and body design. The 3 degrees of freedom leg design allows this robot to walk in any direction. The Hexapod is powered by 18 motors, and all its body components are 3D printed. The best part about this robot is that it is quite possibly the finest looking commercially accessible hexapod out there. The robot is constructed using ultra-durable, high-quality aluminum servo erector set brackets. It should be noted that while this robot is visually appealing, it misses the payload carrying capacity of Lynx Motion's other hexapods. There's a cost for only pivoting the joints on the servo output shaft. The sad part about this is that not much of the bot is available on the internet currently. Number 4, Bionic Ants. Yes, let's take a break from spiders and take a look at some smart ants. Speaking in short, these devices are meant to stimulate highly integrated and individual systems to solve a common task in order to increase efficiency. The Bionic Ants show how individual units may react autonomously to diverse conditions, cooperate with one another, and behave as a network system as a whole. The artificial ants move an object over a given region by pushing and pulling each other. They're able to transfer burdens that a single ant could not move because of this sophisticated division of labor. Just think about it, this could greatly improve the way everything works, right? Nevertheless, not only the communal working nature of the artificial ants is amazing, even their generation method is extraordinary. For the first time, laser-centered components are therefore adorned with visible conductor patterns by using the so-called 3D MID process. The electrical circuits are connected to the surface of the components, thereby taking on layout and electrical processes simultaneously. In this way, all the technical elements can be suited into or on the ant's body and be precisely related to each other. After being put into the process, an external supervising system is no longer expected. Still, it is possible to regulate all the parameters wirelessly and make a regulating intervention, so a supervising element is still needed. Anyway, this unified working behavior gives fascinating strategies for future manufacturing techniques. Future manufacturing systems will be established on smart components, which diversify themselves flexibly to numerous production strategies and thus take on chores from a higher control level. The Bionic Ants illustrate how individual members can react unaided to different circumstances, coordinate with each other, and act as a unified networking system. So by pushing and pulling together, the artificial ants shift a large object across a specified area. And thanks to this intelligent division of work, they're able to efficiently transfer loads that a single ant could not shift. That's it, simple. So from the above bots, which one of these would you want to get your hands on, and what are your opinions of it? Drop your views in the comment section below. That's about it for today. Make sure to subscribe to our channel for more content just like this one. And while you're at it, turn on post notifications so that you never miss out on any of our future uploads. Drop a like for the video if you're a massive fan of robotics and AI. That's it for today. I hope you enjoyed the video. We'll meet again in the next one.